Students, you have been given a problem to obtain the Fourier transform of the function f of x is equal to sin x in the interval 0 is less than x is less than pi, and f of x is equal to 0 or otherwise. It has been clearly defined that f of between the limits 0 to pi alone. Now let you write the Fourier transform of f of x, which is equal to 1 divided by square root of 2 pi integration of minus infinity to plus infinity f of x into e power I s x into dx. Now let you define f of x in various intervals. So the Fourier transform of f of x is equal to 1 divided by square root of 2 pi integration of minus infinity to 0 f of x into e power I s x into dx plus integration of 0 to pi f of x into e power I s x into dx plus integration of pi to infinity f of x into e power I s x into dx, and this will be equal to 1 divided by square root of 2 pi integration of minus infinity to 0 into e power I s x into dx, because the function f of x is 0 between the interval minus infinity to 0, plus integral of 0 to pi sin x into e power I s x into dx. So in the interval 0 to pi f of x is equal to sin x, plus integral of pi to infinity 0 into e power I s x into dx. In the interval pi to infinity also the function f of x is equal to 0. Now we clearly know that the function is existing between 0 to pi alone, so it has been written as Fourier transform of f of x is equal to 1 divided by square root of 2 pi integration of 0 to pi e power I s x into sin x dx. E power I s x into sin x dx is of the model integration of e power ax sin bx dx. Integration of ax into sin bx dx can be given by e power ax divided by a squared plus b squared into a sin bx minus b cos bx. Here a is equivalent to is, b is equivalent to 1. Now let you apply this formula to the given integration. It is equal to 1 divided by square root of 2 pi e power ax. A is is, so it is e power ix divided by a squared plus b squared. A squared is is, so is the whole squared plus 1 squared, it is 1, into a into is into sin bx. Sin bx is sin 1x, so it is written as is into sin x minus of b into 1 into cos bx. Cos bx is cos 1x, so it is written as minus of 1 into cos x. The limits are applied between 0 to pi. Now let you apply the limits from 0 to pi. Applying the upper limit, pi is into sin pi will become 0 because sin pi is equal to 0, and applying the lower limit also to the first term is into sin x, it is becoming is into sin 0. Sin 0 is 0. So by the application of the upper and lower limit to the term is into sin x, it is making all the terms equal to 0. The only term existing is minus cos x. Now let you apply the limit to e power ix divided by is the whole squared plus 1 into minus cos x. Now let you apply the upper limit. When you apply the upper limit, it is equal to 1 divided by square root of 2 pi e power isx will become e power is pi. In the denominator, is the whole squared will become I squared into s squared. I squared is minus 1, so it is making is the whole squared as minus s squared. So the denominator has been written as 1 minus s squared. Now let you apply the upper limit. Already there is a minus sign, so minus cos pi it is. So as per the formula, a minus sign would be coming. So minus of, apply the lower limit to e power I s x So applying the lower limit 0, e power isx will become e power 0. So e power 0 is equal to 1. So it has been written as 1 divided by 1 minus s squared, and minus cos x will become minus cos 0. Minus cos 0 is minus 1, and in the first term cos pi is equal to minus 1. So minus of minus 1 will become plus 1, and in the second term also minus of minus 1 will become plus 1, and both the terms are having 1 minus s squared in common, so it can be taken outside of the bracket. So Fourier transform of f of x will become now 1 divided by square root of 2 pi 1 minus s squared into e power is pi plus 1, and it is written as 1 plus e power is pi divided by square root of 2 pi 1 minus s squared. This is the required Fourier transform of the given function f of x.